Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma, tau, epsilon, phi, chi, psi, omega. Hello friends, Eli Hibbett here with the Pwn Your Homework Physics Series podcast. If you're looking to prepare, review, or gain an added edge or point of view about topics in physics, then look no further. Tune in each week to unlock your understanding of the physical world surrounding us. And now let's dive right in. Alright, hello friends, how's everything going today? I'm your host Eli Hibbett, and this is another edition of the Pwn Your Homework Physics Series podcast. Today we're going to get into Greek letters, and one of the things that I think makes physics so inaccessible off the top is the fact that there's so many crazy symbols going on. When you look at chalkboard, when you look at the mathematics, not only are you seeing numbers and math, which most people don't really even like to begin with, but then you see integral signs and derivatives and exponentials and variables, which can be intimidating enough. But then on top of it, we have these other symbols, which for most, let's say at least Americans, they don't come across them really ever. And so now you're seeing these symbols that are foreign and you don't know what they mean and you don't know why they're there, and you start to think, I'm not going to be able to hack this. I don't even know where to begin here. And so I think that taking a look at the Greek letters, which is where we get most of our symbols from, can really get rid of that alienation and make the whole thing a lot more accessible. I think the first thing that is really important is that when you're looking at a chalkboard and you see all the math on the board and you're not really sure where to start, all the symbols that you see just stand for one certain thing. It's just saying these symbols, especially the Greek letters that we're going to be talking about today, just stand for a value. They just stand for resistance or angle or acceleration. And it's just a number that you plug in. As far as, mathematical operations like integrals or derivatives, it's just saying, do this thing. Add these things together. Make this, calculation. And so once you learn how to read, once you learn how to read this way, it becomes very easy and the relationships become very obvious. And so once we sort of demystify these Greek letters, we're one step closer to making we're going to be bringing you one step closer to becoming mathematically literate. How about that? So one thing that I have is a 3-step method for learning. I think that just looking at, in this particular context, the Greek letters, let's just look at them. Let's get it out there and just see what we're dealing with. Even if you don't know anything about them, you don't know which one is which, you don't know the names, you just see the symbols. And then the next time you see them in class, you see them in the book, you say, oh, I've seen that before. I don't know exactly what it is, but it's not a symbol that I've never ever seen in my life. So the first step, the first wall is already broken down. The second step is to sort of take a look at the list and sort of start associating names and say, okay, this is an alpha, this is a beta, this is a gamma. Now I know when I look at that, oh, that's a gamma. And what does gamma mean? And now we're one step closer beyond that. From there, I would say start reviewing them. Let's really drill it into your head and say, okay, now just looking at the symbol, I can pull right off the top of my head. I know that this is a pi. I know that this is a tau. I know that this is a rho. And now you're very familiar. Now you're starting to feel more comfortable. And so what I've developed an app that's free to download from the App Store and iTunes, and it's a Greek letter app. And we kind of go through these 3 steps. The first step, I'm actually going to open up my copy here and kind of just walk through a little bit of it here. The first thing that you come to is a menu, and we have Greek letters list, tap review, and flashcards. So, like I was saying before, let's just go through the list. We have alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma, tau, epsilon, phi, chi, psi, omega. And I mean, you can find this on the internet. You can go to my website, which I'll link up in the show notes, which has a list and the flashcards, or you can go to Wikipedia or just Google search Greek letters, and you'll be able to find this stuff. And just go through and look at it and say, okay, this is what an alpha looks like. This is what a beta looks like. And you're going to start getting a little bit more familiar with it. We have uppercase and lowercase letters, just like we have in English. And so I would say, for the most part, the symbols are lowercase that you use. But every once in a while, we do run into some of the capital letters. So you really do have to be familiar with both. But I would say if you're going to focus on one case set, I would focus on the lowercase, because you're going to see a whole lot more of those. And I thought something that would be really useful to kind of go through in this whole demystification process is some of the mission critical symbols, I guess you'd say, that you are definitely going to come across in introductory physics. And once you say, okay, well, this just means this certain quantity, when you see it in class, when you see it in the book, you're going to be a lot more comfortable. So I'm just going to go through a couple that I know you're going to see eventually. Uppercase omega. This is actually the unit symbol for ohms, which is of the way we measure resistance. Lowercase alpha is a measure of angular acceleration. This is like how fast you're accelerating when you're going around a curve, like in a car. But you say, okay, the angular acceleration is 2.5 radians a second. I mean, that'd be really zipping. But then now all you're going to do is replace that alpha that you see in your equations later with a 2.5. That's all you have to do. So once you know that alpha just represents any angular acceleration, now you can become a little bit more comfortable with it. We actually have a couple of particles. We have a beta particle and an alpha particle. And they just have these names. We just gave them names because in the beginning they weren't really sure what they were. And so they just threw some names on them before they could really distinguish what they were. And so they gave them Greek letter names. And there's nothing fancy about them. One of them is something that happens during decay. Sometimes you get a beta particle. An alpha particle is just 2 neutrons and 2 protons. That's a helium nucleus, I guess you could say. These next two that we're going to go through, I would say you are going to come across in almost universally in any subtopic of physics. You're going to see theta and phi, which commonly represent angles. So when you see cosine theta, that's talking about an angle. Cosine phi, that's an angle. Usually you have more than one angle in a problem, so we need to have a couple of letters to designate angles. And capital delta, meaning the change in a quantity. So if you have something happened in 5 seconds, event X happened in 5 seconds, the change in time, delta T, is 5 seconds. So what we did there is we just subtract the initial quantity, or the final quantity, let's say, from the initial quantity. 5 minus 0 equals 5. But that happens a lot. We want to know change in acceleration, we want to know change in velocity, change in time, change in distance, change in current, change in voltage. These are all, we just throw a delta, capital delta. It looks like a triangle. You put that in front, and you know exactly what they're talking about. In terms of summation, or a product, if you want to add a bunch of things together, if we want to add up all of the little distances together, we will say sigma, capital sigma. It looks kind of like an E. Or if we want to multiply a lot of values together, we'll put a pi. That means a product of all these values, and we'll give them little subscripts like C sub I, and I goes from 1 to 5. We just add up C1, C2, C3, C4, C5, whatever C is. And then you know exactly what that means, and now you're not really afraid of it anymore. And so I think that is a big wall. And I remember when I was in high school, I didn't have any really good way of finding out what any of these things meant. And I mean, that's where the phrase "it's all Greek to me" comes from. When you see it, it's so uncommon for our culture to come across these things. And I think with the internet and physics and science becoming more and more in the limelight, that's becoming less and less of the case. But at least when I was younger, I never saw it, I didn't know what it was, and I had no resource that would tell me what it was. So that was sort of the thought behind the app that I built, was giving you this way of finding out exactly what it is. And then when you're in the car, when you're driving, when you're taking the bus, Go through it. Just take 20 seconds, take 30 seconds when you're standing in line at Subway, and go through this and drill it a little bit, and it'll start to sink in. And this is the real critical thing. When it starts to sink into your subconscious, and when you see it and you know exactly what it is, hey, that's a delta, hey, that's an alpha, hey, that's a beta, then you start really feeling like you're in the driver's seat. You start feeling real comfortable with the symbolics and the language of mathematics. And it becomes a lot more approachable and actually a lot easier. It's like you're actually able to concentrate on what you're doing instead of worrying about not knowing what's going on. Instead of looking at all these things, you're like, okay, I don't know what that is. I'm sort of crippled here and not able to move forward until I figure out what that is. You start looking at it and saying, okay, I'm actually familiar with all these symbols. Now all I need to do is just perform the action, do the calculation, break it down, and it becomes very step-by-step driven. And then all you have to do is just go through the steps which you already know how to do. And this is a big wall that I think a lot of people give up way too early on. They don't want to go through it. It's a very difficult thing because you feel very vulnerable. You don't know what anything is, and you have to tell somebody, I don't know what any of this is. But that's okay. There are people there who will tell you what all these things mean and take your hand and walk you through it. And when you get through it, when you feel confused, I just read something on Twitter where someone said that confusion is the sweat of learning. And especially nowadays, nobody likes to sweat. I like to sweat. But it's a very uncomfortable thing. And what you want to do, nobody likes to feel uncomfortable. And I don't really fault anybody for that. But when you feel uncomfortable and you achieve something and you become comfortable again, there is nothing better. It's like the best feeling that you could possibly have. And so I would say if you're feeling nervous, go to my website, 2718productions.com/Greek letters, or download the app, or go to the internet and just find out, because we live in an age now where you don't have to ask somebody. You can find out for yourself. But if it's still confusing to you, just ask somebody. Ask your professor, ask one of your high school teachers. Someone will be there to help you out and guide you through it. And I'm telling you, it's worth it. Pretty much for this app, the whole thing is available on my website, which I will link up. And so you can go there if it's easier for you to be sitting at a computer, or if you want to hit it on the go, you can download the app and check it out on the iPhone. I don't want to push it too far down your throat, but I do think it's a really good tool for learning about the Greek letters. One thing I guess I forgot to mention at the beginning was that my symbol for this Pwn Your Homework podcast, which kind of comes from pwned. That's like a gamer phrase about owning people. And so when we were in college, we came up with this idea that we wanted to have our own fraternity, and we were going to call it Rho Omega Eta, so that it stood for Pwn. And it's, even that, it's Rho Omega Eta. It doesn't spell Pwn, but it looks like it. Visually, the representation is there. And that's carried on with me for over 10 years now. And I liked it when I was thinking about what I was going to do, when I was going to name my podcast. It immediately, there was no second thought. It was just, this is what it's going to be. So I derailed a little bit here. Let's get back into pi. I'm sure you've probably run across pi. And pi is an irrational number, which is essentially just a ratio between the circumference and the diameter of a circle, because we know that their circumference is equal to pi d, or 2 pi r. And so if you take the circumference and divide it by the diameter, if it's calculated properly or measured properly, you should get at least 3.14 and go quite beyond that. But we've taken this value, which we've seen recur over and over, and you're going to use it millions of times. You should at least know 3.14. And we just call it pi. So when you throw it in, you don't have to worry about that number colliding with other numbers. You just put a pi in there. Everybody knows what it means, and you can move along and get it done. Lowercase omega represents angular velocity, which is like how fast you're traveling in circular motion. Tau represents torque, which is like if you're pushing around like a fulcrum point some distance away, you're not applying a direct force, you're applying some distance away. Rho is a very common lowercase rho, represents density. In wave analysis, lambda represents the wavelength, and then English F represents the frequency. And then in quantum mechanics, there's something called the wave function, which I'm sure we'll dedicate several episodes to later on, is represented by an uppercase psi. So that is just a little taste of it. But if you go through and you know all the letters, when you see them write them on the board for the first time, or you read them in the book, you say, okay, I know what that is. And you can kind of feel that security and move right along. So what I've done is, I think there's two real ways of describing this. I've taken this very conversational approach in the podcast episodes, and then I thought it would be good to kind of formalize it and make it almost PowerPointy, and I made a series of formalized kind of semi-scripted YouTube videos. So if you like a little more formal way of learning things, I'm going to link up the YouTube videos in the show notes. You can check those out. And I think that there's a lot of tools there. Website, app, YouTube videos, podcast. If you go through those, you're going to be very familiar with the Greek letters. And hopefully that'll make you feel more comfortable when you're going through your coursework. This segment, coming back a little bit, one kind of conversational physics item. I found this WordPress site, jameskennedymonash.wordpress.com, and I'll link that up. And he has a very interesting poster. And I mean, if Greek letters are intimidating to you, this will certainly remove all the intimidation. He took a couple of very common Greek letters and put them in with these funny little cartoonish icons. And he has like an alpha for alpha particle, beta for beta particle, gamma for gamma ray. Let's see what else is good here. Lambda for wavelength, mu for magnetic moment, pi for 3.14, rho for density, things that I've already covered. But he puts these little cartoons there, and when you kind of put it that way, it really removes the barriers even more so, I would say. Because once you put a cartoon to something, it cannot be scary. It's a scary cartoon, I guess. But this is great, and something that if I was a high school teacher or if I had a room to hang it in, I would certainly put this up. And I will certainly show it to my little 2.5-year-old daughter and my 3-month-old daughter when they get to that point where they can start to appreciate that sort of thing. But I'll link that up in the site. I'm also going to include an image so you can check it out on the blog. Check it out, check out the site. And I liked including this one because it's sort of relevant to what we're talking about, but there are some things on this site that are really noteworthy. And I think that you should really get lost in science. I don't think that it's a, well, I'm a physicist, so I only look at physics, but this guy looks like he's a chemistry teacher, and he has some really cool things. I love Dr. Dre and Beats Music and Beats Audio, and he has this really cool poster about the chemistry of beats and about how there's this neodymium magnet which is used to make the sounds and vibrate against the diaphragm to create the sound in Beats headphones, and how there's the gold audio plug and how gold is a really good conductor but copper is a better conductor, and that there's this anodized aluminum frame, and kind of the nitty-gritty of the mechanics of what makes this really, what I feel is a very wonderful product, the Beats headphone. But it gives you a little deeper understanding of what goes into making something that incredible, and I think it gives you a deeper appreciation. I mean, when this music is so crisp, that ain't easy. That's not an easy thing to come across. I mean, we've had to go through a lot of work to create something that sounds that good, and I think when you put a little price tag on it that's feasible for anybody to buy, kind of cheapens it a little bit. But when you start looking at the mechanics of it and what has all the effort and science that's gone into developing it, you really start to appreciate it. And I think he did a really good job with that poster. He also has a couple cool other ones. I'll probably link up in the site. The chemistry of the Lego brick, the melting point, and what goes into building the different color Lego blocks, and what goes into making the plastic of the Lego blocks. And he also has these really cool posters that are the chemistry of like fruits, and kind of like how you have on like the nutrition fact on the back of any cereal or whatever you buy at the store. It tells you the ingredients list. he took these ingredients, but he put all the chemical names for all the chemicals that are in, let's say a pear or a coffee bean or a strawberry. And there are all these posters that you can get, and I think they look fantastic. So I'll send you a link over there if you like it. Check it out. And yeah, I think with that, we just about covered it. I would say that just one parting piece of advice: if you are scared or still intimidated and you're looking for resources, don't worry about it. Just dive in and try it out. And don't try to push the envelope a little bit. Don't let the envelope hold you back. Don't try to bring yourself up to the bar's level. Don't try to bring the bar down to your level. And I think if you go with that advice, you're never going to go wrong. So let me just beat you over the head one more time. Get the app. Go to 2718productions.com. Check it out. Linked up in the show notes. Check us out on Twitter. And I think that's going to do it. Oh, and if you just come across this podcast some other way, Pwn Your Homework, pwnyourhw.blogspot.com. So, with that, I'm going to sign off. I wish you the best. Stay frosty, stay motivated, and I'll catch you next time. Take care, guys.